Hello everyone, and welcome to our last unit that we are going to go ahead and review. As I said a couple times, we are not going to review Unit 5 after this because that was our newest unit. That was also the unit that we started this online learning with. So if you really can't remember anything about Unit 5, which was the types of energy, go ahead and scroll all the way down on Google Classroom and there are a couple videos. There's a video that I made over it, and I think there was an ed puzzle as well over the different types of energy. So if you need to refresh your memory, you can go ahead and go back by just scrolling down and checking out the Unit 5 stuff. So we're going to go ahead and review Unit 4, and then we're going to go ahead and move on to Unit 6, which is our last and final unit, which is life science, and that is all brand new information. So it's going to be very important that you're tuning in every day and doing the assignments because this unit is very important to prepare you for 7th grade. So let's go ahead and get started. Unit 4 was over particles and matter, so we're talking about atoms and protons and neutrons and electrons, and we're talking about molecules and compounds, things like that. So the first thing that we talked about were atoms. Atoms are the smallest unit of an element or matter, and they're made up of protons, which are positive, neutrons, which are neutral, and electrons, which are negative. So looking at the screen, you see an example, you see an atomic model here. And in the center, we have protons and neutrons, and around the outside, we have electrons. You can find them in orbitals, or sometimes you'll hear it called electron shells or electron clouds. Now remember, that first level can hold 2, the second level can hold 8, and then depending on what you're working on, that third level can hold 8 or 18, but there's different reasons for that, and that's a little bit beyond us right now. So we'll just stick with 288 for now. I know it says 18, but just stick with 288. So moving on, in the center, this is what we call the nucleus, and the nucleus is made up of protons and neutrons. So as we said before, protons are positive, neutrons are neutral, meaning that they have no charge, and electrons, found in the electron shell or orbital or cloud, have a negative charge, okay? And we also talked about that most of the time, the number of protons in the nucleus is also going to equal the number of electrons in the electron cloud. So if you notice, there are 6 protons and there are also 6 electrons. Okay? And then if you remember, how do we find the number of neutrons in the nucleus? You look at the element square, you take that atomic mass, you take the atomic mass and you subtract the number of protons, and that'll tell you how many neutrons are in the nucleus. And we'll talk about that more in a second. So we'll move on for now. So what is an element? Here's an example of an element square, and elements are found on the periodic table. An element is a substance made up of one type of atom. So for example, hydrogen is an element, helium, carbon, neon, krypton, so on and so forth. That's what we made our superhero over. The element square tells us different things, like the atomic number, right here, the element symbol, which is right here, the element name, which in this case is carbon, and then the atomic mass. So here's an example. You can find elements on the periodic table. So here's an example of a periodic table. Remember, periodic tables are arranged in many different ways. And if you remember, periods are what go from left to right. And the way that we remember that periods go this way is that a period is at the end of a sentence, and a sentence goes across a page. So these are periods. And then groups or families are up and down. So for example, this is group or family number 16. Okay, and these guys would be period 3. So you would find helium in group or family 18 and in period 1. Okay, remember that we read the periodic table from left to right. So hydrogen would be number 1, helium number 2, lithium 3, 4, 5, 6, 7, just like that. Now remember, the atomic number is at the top, so helium's atomic number is 2. The atomic number is always equal to the number of protons. So helium has how many protons? 2, right? The atomic number is almost always equal to the number of electrons. So helium has 2 protons and 2 electrons. Now, how do we figure out how many neutrons it has? Well, you take this atomic mass, which is, rounding it, is 4, and you subtract that atomic number, or the number of protons. So 4 minus 2 is 2, and that's how we figure out the number of neutrons. So helium has 2 protons, 2 neutrons, and 2 electrons. Now, I do want to take you to ptable.com. This is an awesome periodic table. It's an interactive periodic table that you can move around. And you can even click on the different elements, like how I did, and it'll show you how copper looks. It'll show you different, lots of different information on each and every element. So if you get a chance, go to ptable.com and play around with the periodic table of elements. It's actually very cool. All right, moving on. So looking at this, we have a compound here. We have a compound called iron oxide. And the question is, what 2 elements are in this compound? Well, Fe is iron, and there's 2 of those, and O is oxygen, and there are 3 molecules of oxygen in this compound. So speaking of molecules and compounds, if you remember, molecules are when 2 or more atoms combine. So for example, O2, N2, H2O, CO2, okay? It's just 2 or more molecules of anything. It can be the same element, like O2, or it can be different elements, okay? What are compounds? The difference between molecules and compounds is that compounds is made of 2 or more different elements. So in this case, O2 or H2 is not a compound because that is 2 or more of the same elements. So H2O is a compound, CO2 is a compound, C6H12O6 is a compound. Remember, all compounds are molecules, but not all molecules are compounds. So, looking at CO2, is this a molecule, a compound, or both? It's both. And oxygen, that's O2. Is that a molecule, a compound, or both? If you don't remember, we'll go back. 2 or more different elements. O2, is that 2 or more different elements? No, it's not. So that would just be a molecule. All right, so then we moved on to matter. Notice that we're building up. We started with atoms, and then we moved up to elements. Atoms make up elements. Elements make up matter. Okay? So matter is anything that has mass and takes up space. Matter is made of particles that move differently depending on what state it is in. Solids, they stay in, the particles stay in place. They're tightly packed. They move slightly. They vibrate. Liquids, they move or flow around. They don't separate from each other. A lot of times they're in chains. And gases, they move freely and they bounce around like crazy. So here's an example of particle arrangements in a solid. So you notice that they're vibrating in place. A liquid, they're flowing around in chains. And a gas, they're moving in all different directions and they're spread out. So matter can change states or phases by adding or removing thermal energy. And we said every time you hear thermal energy, you need to think of the word heat. So for example, if I have a solid ice cube and I add thermal energy or I add heat to it, that's going to take it from a solid to a liquid. If I have gas and gas changes into a liquid, for example, your glass is fogging up when going from hot to cold, that's condensation. That is a state change, okay? So by adding or removing thermal energy, so if I have a glass of water and I remove the thermal energy, I put it in the freezer and it turns into a solid, that is a change in states or phases. Then we also talked about properties of matter. So physical properties are things that you can experience with your senses, your sight, your smell, your taste, your hearing. I feel like I'm missing one. Oh, and your touch. Okay. So you can identify just by looking at things the state that it is in. You can measure size, density, volume. You can look to see what shape it is. You can feel the texture. You can look and see the color. You can smell the odor. You can feel the hardness of an object. Chemical properties are the ability to do something. So for example, is it combustible? Can it explode? Is it toxic? Is it poisonous? Is it flammable? Does it light on fire? Can it oxidize, meaning rust? Does it react to other other things. So those are the properties of matter, the physical and chemical properties. Physical properties is, again, a characteristic of a substance that you can measure or observe. Size, shape, state of matter, color, weight, mass, density, things like that. And chemical property is a characteristic of a substance that can be observed during a chemical reaction, meaning that it has the ability to change. So for example, is it reactive, flammable, toxic? Can it rust? Oxidation, or is it combustible? All right, and actually that is my last slide. So that was our review of Unit 4. I'm kind of going back here. I want you guys to see again that we are building up. So we're starting at atoms, and atoms are made up of protons, neutrons, and electrons. Then we went to elements. So atoms make up elements, and then elements make up molecules and compounds. Molecules and compounds form together to make matter. So we were starting from the smallest, getting up to the largest. Remember, matter is anything that has mass and takes up space. It's you matter, tables, the chairs. Here's a question for you. Is the air around you matter? If you said yes, you are correct. Air does take up space. And as I told my students over and over, and I know Miss Thomas has told her students too, that, and we can prove that air takes up space simply by blowing up a balloon or inflating your car tire, or when we breathe, our lungs inflate and deflate. So air is definitely matter, and it definitely takes up space. So I did want to go back and just show you the building blocks of matter. All right, guys, so what you're going to do is you're going to head back over to Google Classroom, and there I did put a Google form there with 10 questions for you. So go ahead and answer those 10 questions for me. Have a great day. Talk to you soon. Bye.